Hi everyone, welcome to Workshop 3 in the Polkadot Inc. Bootcamp. I hope you're looking forward to learning how to create multi-chain contracts with Inc. Peter, I'll hand over to you.
Perfect, thanks so much, Rebecca. Hello everyone, I'm Peter, and I'm also part of Rogue. You may have seen some previous talks with Bruno. And today, this presentation I'm pretty excited for because it's something that it makes me really excited. I always have fun playing around with this, and I'm excited to show it to you. And I wanted to start with this. It's probably something you've seen already, especially if you went to the Polkadot education series with Encode Club. But you've got the Polkadot Relay Chain, and then you have all of the parachains with their specialized functionality. They do specific things, and they do specific things. A lot of them do different things. The thing is when you're building a smart contract and you're deploying on a parachain, how do you use kind of the power of Polkadot, the offerings that Polkadot is, which is composability of many, many services? And it's kind of what we're answering today. And the answer is actually Inc with XCM. So Inc is, of course, the smart contract language for Polkadot, and it has native XCM support built into it. Now, what is XCM? You probably learned it already, but I'll briefly go into that as well. So what we're going to do today is we're going to do a brief introduction to XCM, and in particular, mostly just dive into the locations. And then we'll actually use XCM to interact with the local parachain. We will transfer funds on different parachains and even the Polkadot Relay Chain. And then the one I really, really like is the generic execution. So you can just provide a generic encoded call hash, and you'll call things on AssetHub, you'll call things on Polkadot, and you call things even locally on Pop Network. So let's go ahead and jump into what is XCM. So XCM is cross-consensus messaging. Now, what's important there is it doesn't necessarily say cross-chain messaging. So what this means is because it's just cross-consensus, not necessarily cross-chain, you can use XCM to interact with the local chain that your smart contract is actually deployed on. So this means your smart contract, or your Inc smart contract rather, isn't just limited to calling other contracts. You can actually call into palettes and modules and specialized functionality that the parachains offer, that the parachains offer and have built. Now, when it comes to XCM, the things I'll focus on mostly is the location bit, because it'll be especially useful when we actually start writing some code. So for locations in Polkadot, you have the relay chain. This is Polkadot. And then you have each of the parachains with their own accounts and their own contracts. Now, when you want to interact across parachains, so for example, you've got AssetHub here, and you want to interact with collectives, you can't actually just go, okay, AssetHub is 1000, we're going to go to collectives pair ID 1001. What you actually need to do is you need to go up a level. So you need to go up one parent. So it's kind of like a file system where you just .. you go up one file directory. And then you go to Polkadot, and then you go down into parachain 1001. So here's another example, but this time we're going to start at Polkadot and then make our way down. So we've got parachain 1000, so that's AssetHub, and then we want to get the account ID right here. So it's an account ID in AssetHub, and this is coming from the perspective of Polkadot. Now, if we were starting from this collectives chain, I know it's a little grayed out here, we would actually have to go up one level to Polkadot and then go down. Now, a little more technical in actual code. So if we're going to go from the relay chain to parachain B, we will, we have no parents because Polkadot, the relay chain, is the highest parent. And then we start going in. So we go to parachain 2000. Now this X1 right here is, it's called junction. So basically, how many junctions are there to get to where you need to go? So in this case, we just want to get to parachain 2000. So it's just one, so X1, and then we go down. Now, if we want to go to an account in parachain A, this is still from the perspective of the relay chain. Once again, there's no parents because Polkadot is at the top. And this time there's actually two junctions because we're going to an account. So first we go to parachain 1000, and then we go to an account. So what this represents is an account on parachain 1000. Now, this is kind of just going up now because we're going to the relay chain. So it's from a parachain B to relay chain. So this time there is a parent because the relay chain is the parent of the parachain. So we have to go up one. And then we're just going to the relay chain. So there is no further steps. So it's just here because it's already, once you go up one level, you're already there. Now, this one is to an account in a different parachain. So this is from the perspective of parachain B going to parachain A. So the location in this case is, well, we have to go up one level because we got to go to the relay chain. And then we go down into the other parachain, into the sibling chain. So now we go to parachain 1000, and then we go to the actual account ID over here. Now, the reason I kind of went into this is because there's something called computed origins that we're going to have to deal with as we do multi-chain contracts. So basically, we have an Ink Smart contract that is deployed on POP network. Now, this Ink Smart contract wants to now use, or say, let's just a simple example, transfer funds on the Polkadot Relay Chain. Now, as we all know, in blockchains, you always have to pay the fees for actually transacting. So there needs to be an origin. There needs to be some sort of address that has funds to actually call this on the Polkadot Relay Chain. And the way this will work is we've got the Ink Smart contract and we've got the POP network. So there's this thing called derived origins where you take the smart contract address on POP network mixed with the POP network para ID. And then when it actually hits Polkadot, you get a kind of wrapped account that is keyless. There is no private key for it. And what's cool is it is controllable by the smart contract only. It's the same thing with AssetHub and any of the other ones. Smart contract address with the POP network para ID is then equal to this keyless account. And this keyless account is represented on the actual destination chain. So whether that's the Polkadot Relay Chain or if it's AssetHub or wherever else you may want to interact with. Now, what's really cool about this is you now have this keyless account controllable by the smart contract only that is actually native to that specific chain. So say, for example, on AssetHub. AssetHub is the thing that holds lots of assets, USDC, USDT, NFTs, and lots of other things. You can actually have people transfer on AssetHub directly to this keyless account address, and they don't ever need to do XCM messages to your smart contract. They can do it all locally on whatever chain they're native to. So whether that's Polkadot or AssetHub, they can just transfer to this keyless account. You can also just transfer funds there if you want to make sure that you can continue interacting and executing transactions. For example, maybe with OpenGov, if you're familiar with that, you could send funds from OpenGov to this keyless account address, and the only way you can actually access those funds is through an XCM message from Ink. So I think this is really, really cool, and I'm excited to actually show you this in the code. I'm sorry, this one slide. And that's what we'll actually get started to do. So that was just a brief introduction, and then let's actually dive into some code. So first things first is I'll show you a few resources. So if you want to learn XCM yourself, there is this XCM documentation. I know this link is a little hard to see, but it's paritytech.github.io/XCM docs. Usually you can just search XCM docs, Polkadot. But it goes into a lot of the location stuff and making transactions and really whatever you need. So, I mean, if we go to the journey through XCM, there's a lot of instructions here because XCM is instruction based. So you give it a list of instructions and the chains will actually continue, they'll execute on these instructions. So a useful one is withdraw assets. And this is basically what you're doing is you're withdrawing an asset into the holding register of XCM. And this can be used for say, hey, I need to pay fees on the Polkadot Relay Chain. So let me withdraw some DOT, and then we can use that to buy execution. So, okay, we're going to withdraw the DOT, then we're going to buy execution to transfer funds or to execute a function. Deposit asset is also a useful one because this is actually, you withdraw the asset, you buy execution, and then you actually have to deposit the asset. Yeah, so that's all I'll touch with XCM, and we can actually jump into coding now. So first things first, we will use pop to create a new contract. So it's just pop CLI, which you can find if you go to onpop.io, super simple link. You can install pop CLI, and you can also find the contract deployment UI, which we will be using. So just click right there, pulls us to contract.onpop.io, and this will be the thing we'll use to actually deploy contracts. And then, yeah, I mean, there's lots of other links you can follow there. But let's go now to a couple other things. Is if you're deploying on Pop Network, you will need some funds. And the cool thing about Pop Network is it only uses the relay chain asset. So in this case, Paseo is the Polkadot testnet. So we'd use Paseo, we'd get the Paseo token, and then we'd come over to here, which is another link. If you've got any questions or you need to contact us, I'll give you the contact information at the end. But you can then use this one, onboard.popnetwork, to actually transfer the funds. This is an XCM message from Paseo over to Pop Network. So now that Pop Network doesn't have its own coin you have to get. You just use the relay chains coin. Okay, now we can actually jump into code. So we're going to create a new contract, not a parachain. Sorry about that. And okay, yeah. So this is just going to be called XCM. And there we are. And so for XCM, and we'll actually pull this up in Rust Rover. Give me 1 second here. All right, here we are. So we've pulled up this contract, and this is just right now it's just starting off with the simple Flipper contract. And what we're going to do is we're going to start inserting some XCM functions. As I mentioned, we'll do just a transferring funds through XCM. We'll do interacting with the local parachain, interacting on the relay chain, and interacting with AssetHub. And we'll do this all on Pop Network. So one thing to note is if you want to use XCM, right now it is actually in a branch. We had to do a couple fixes because there's some metadata, there's some changes in Power contracts. So we had to do a couple fixes. So that's not quite merged in. So we'll have to go to this branch. So just paste this in over here. Basically, all you need to do is you need to replace the version with Git, and you need to point to Inc's GitHub. So it's just use Inc/Inc, and the branch is simply XCM. So that's the only change we need to make there. And now we can go over to the contract. So first thing we'll do is let's just do a simple transfer, and we can do it locally on the Pop Network parachain. So I'll delete these functions here. We don't actually need anything in the storage, so we can delete the storage. Now, normally what you would probably have some things in storage that you could put here that I believe other people probably taught you about. So no storage needed. And there we are. And constructor, since there's no value, we'll just get rid of this here. And we'll just return. We'll actually just leave the default one, I think. So we'll just set this to new, and we'll just use the default for the constructor. Okay. Now, the test we also don't need. Sorry, just doing a little bit of housekeeping here. There we are. Okay, so let's actually go ahead and write an XCM function. So as usual, so all Inc functions that are callable need to be prefaced with this Inc message here. And we'll just name this transfer through XCM. Now, there's a few things that we may want to pass in. So first, we do need to pass in self. And then what is the receiving account that we actually want to transfer the funds to? And then the value. And we'll go ahead and return the results. And I'm going to copy over a bit of code here that just wraps the error a bit for us to make it a little nicer. So all this is we've got a runtime error, and we're mapping it to the XCM the XCM errors that might happen. So there's an XCM execute and an XCM send, which I'll get to in a little bit. So, okay, down here, and then we're going to do runtime error. And now we actually get to write some XCM code. So I guess Copilot's going to write it all for me, but I'm not going to let that happen. So first thing is we actually need to specify the asset that we need to transfer. So what this asset, oh wow, that is glitching out. So what this asset will be is, because we're going to do a transfer locally in POP network. Now, normally what you could do is you could just do here, right? We're just going to use the asset of this parachain or the relay chain. However, because POP network actually uses the asset of the relay chain, we need to use that one. So we would do location, and actually, sorry, I need to import some stuff now that I realize. So at the top in here, we just have to import some support for XCM. So you use Inc, and then we can import the XCM prelude, which pulls in a lot of useful things like location and the XCM builder and things that allow you to actually work with XCM. So now we can just do, okay, location and parent. So what that does is this is basically just saying, all right, the location is up 1 to the parent, and that is the location of our asset. And we want to transfer that value that was passed in up here. And then we do need to actually call that into. And then we need to do the beneficiary. And I suppose maybe it could be easier to actually look at this just regular XCM first. So if we go to extrinsics, so this is just in the Polkadot.js, because this is just XCM messages, not special to Inc. So if we wanted to do a transfer locally, we could set it up here. So we would do an execute, and we'd set up our messages. So we'd have to do withdraw asset, and then the, sorry, I'm forgetting the message. And then the by execution, which is actually purchasing the execution to do the transfer. And then the last one that we would have to add is deposit asset. Now this deposit asset, this is the important bit for the actual transfer. What this is saying is we're going to take this asset that sorry, let me take a step back. So first, we're executing a message on XCM in POP network. We need to withdraw an asset, in this case dot, to purchase the execution for doing the transfer. And then we call deposit asset, which is the last bit, which actually deposits the asset from the contract into the beneficiary account. Now we're just setting up this message in a contract, in the Inc smart contract. So now we would do the beneficiary, which is an account ID 32. The network isn't important because we're just using it locally on the POP network chain. And then we have the actual ID of the person. And then we need to actually write the message. So these are just the parameters that are going into it. So message is an XCM message. And there's this really useful thing that's called the XCM builder. And the XCM builder is just something that kind of takes away a lot of the pain of having to write XCM messages manually. And we can just insert the instructions one by one. So we would do withdraw asset first, because we need to purchase execution time. And we have to withdraw the asset from the contract account. And we'll pull that from this asset here. And once again, this location parent is saying this is the relay chain token. But in this case, it's local to POP network. And then we need to purchase the execution. So we're doing a transaction, which, as you know, need to pay fees. So we will purchase the execution with that same asset. And then this unlimited here is saying how much weight can we go up to? In this case, we'll just do unlimited, which will allow us to, it'll go up as much as it needs to transfer the asset. And now deposit asset. So this is the last step for a simple transfer of funds locally. And we'll do there. And then we need to input the beneficiary address. And then dot build. So to walk through this whole XCM message again, we use the XCM builder to build the message. And each of these are instructions. So we're going to withdraw the asset, which will be used to purchase execution time locally, and then we'll deposit that asset into this new account over here. And now let's actually do something with that message. So this is where Inc has it built in natively. So all you have to do is self, which is the Inc smart contract, and then environment. And we're going to do an XCM execute. Now, the importance of the XCM execute is that this is executing something locally. The XCM send, which we will use next, is sending something from the local chain to the new chain, to a different parachain. And XCM is version. So this makes it basically, because blockchains can be immutable, especially smart contracts, you want to make sure that they rate it in such a way that it is versioned. So if a parachain is only using version 3, or if your smart contract is using version 3, and they release version 4 or version 5, then your smart contract will be okay, and the other parachains will be okay, because the XCM messages that you were sending will continue to be supported. So we'll have to do a version XCM message, and in this case, we're going to use v4, because that is the latest, and then we'll just map the error. So this is everything for the local transfer. Now, if we were to build this and deploy it, it should actually work. So we do cargo contract build, and we'll build it in release mode. And hopefully, okay, this is building. Hopefully it doesn't fail. Now, what's going to happen next is we can actually deploy this contract on Pop Network, and we'll transfer it some funds, and then we will, got errors here. So use of undeclared type runtime error. So I probably just made some mistakes when I was just copy pasting code, which isn't the smartest thing. So let me just fix that real quick. So I was missing the actual runtime error type. There we are. So this is the runtime error. There's XCM execute failed and XCM send failed. And we can try to build that again. Okay, last error. All right, I'm breaking things. I need a, there we are. Okay, there we are. Okay, that should be fixed now. All right, one more error. Function or associated and not found in XCM. So I probably broke it by calling it XCM. So what I'm going to do, so I'm not wasting your time, is I've got a fancy contract that's completed over here. It is my cheat sheet in case things go wrong with workshops like they usually do. So we have this transfer through XCM function. It's the same thing we just wrote. It's just make sure everything was imported correctly. So to walk over the imports, first we import the prelude from XCM, which includes all of our nice XCM messages. And then here's our runtime error and the mapping. So transfer through XCM, exactly the same, nothing new there. So if we build this, this will work. Now, we can go over to our contracts UI, and you can do this with the cargo contract or Pop CLI to actually deploy the contract. But I added some useful things for XCM here that will allow you to, those calculated address I was telling you about over here, if this wants to work. Okay, right here. So these ones, they have to be calculated. And basically in the contracts UI, we've got a nice little section where you can just look at it, copy the addresses, and then you'll have it for the relay chain, and you will have it for AssetHub. So let's go ahead and deploy our contract. I'm going to pull up my Finder and just drag this over. So there we go. So we just dragged over. Basically, you go to your XCM message, your XCM contract, target, Inc, and then you want to pull over the contract, which includes the metadata and the WASM file. And that pulls up all of this nice stuff for you. We'll deploy it. And it's going to Pop Network Testnet here. And we're just using Alice's account. All right, here we are. So transfer through XCM. So in order to transfer this, we need some funds for that account. So I'll copy the address here and then go over to Pop Network, and I'll send it some funds real quick. Send it 1,000 Paseo. All right, so that should go through in just a second. There it is, and it shows here 1,000 Paseo. So now we can actually do the XCM transfer. So we'll put in transfer 10 paseo, and let's make the receiver this account here. And we'll be calling from Alice, call contract, sign the transaction. Okay, so this one, not much is going on, except that we're just locally, instead of doing balances.transfer, we're going to use an XCM message to do the transfer ourselves. And as we can see, this Polkadot XCM attempted was called because the contracts called it. And there should have been a balance transfer in one of these events here. So maybe we have to go in and look. Yeah, so there we go. That was transferred or deposited in. It's not called transfer because it's actually deposited into the account. So nothing super fancy for that one, but we have some other XCM messages here that we can play around with. So let's do generic execute local. So this one here is we're going to actually execute and use the parachain runtime locally. So we're going to pass in this encoded extrinsic, which I'll show you what that is. So in Pop Network, if you go to the extrinsics, this is basically in your parachain runtime, you've got these different paths, different modules that you can use. So for example, there's the balances one where you can transfer balances, but that was a little boring. So maybe let's do utility. Now utility, this is a cool one because this allows you to batch a bunch of calls together. So we'll do batch all, and let's do an assets one where we will create an asset. So this is, you know, like a ERC20 or a PSP22. So we'll create a token and we will set the minimum balance. So let me copy the contract address while we're at it. Okay, so the account ID the admin of this asset will be our contract that we just deployed. And then you see here, there's this encoded call data. So we want to use this encoded call data and we can pass it into the XCM message. Now, of course, if you're using like JavaScript clients like Polkadot.js or Poppy, then you can actually generate this encoded call data just in your front end and pass it into your contract that way. But we're doing it manually for now. So the generic execute local, let's go over the code one more time. So encoded extrinsic, this is that call data that we just copied, this one right here. And all this is saying is we're going to do a utility call, we're going to batch the calls, and we're going to do assets.create. And let's add another one while we're here, where since we're batching many calls together, we'll create the asset, and let's make sure we don't have a conflicting ID. So I'll just choose 50. And then we can actually mint that asset into somebody's account. Sorry, just looking for mint, there it is. We're gonna use asset 50, and we will transfer it to Alice's account, and we'll give her 10. So we've got this batch call. We're going to create an asset, and then we're going to, in that same transaction, mint an asset to Alice's account. So as you can see, the encoded call data grows because there's more information there. So back over to our contract. So that's what we pass there. And then we're going to specify something that says, how much fees do you actually want to pay when you call this message? And then in Polkadot, in parachains, there's actually, for weight, there's two calculations, which is the reference time and then the proof size. How big is the actual message? And it's the same thing, right? So we've got the asset here. And because it's local on the Pop Network parachain, but the Pop Network only uses the relay chain token, we have to use the parent asset. And it will be a maximum of fee max. And then we're going to set up the message. So once again, XCM builder. We withdraw the asset and purchase the execution time to actually do this message. And then we're going to call the transact. And this transact is a new instruction, which is basically saying, let's take this encoded extrinsic and let's execute it. We'll transact with that on the chain. And then, of course, you have to specify the weight. How much weight do you actually want to go up to? How much weight are you allowing your contract to execute? We take this message, and we're going to use XCM execute, which once again, XCM execute is saying we're going to execute something locally on the parachain that our smart contract exists on. and we have to do a versioned XCM message, and then we pass in the message. So the difference between this one and the first XCM message we did is it's a different instruction. So before we used deposit asset, which said we're going to take this asset and we're going to deposit it into a new account. So it's a different instruction. This one, we're using the transact instruction to transact on the local chain. And once again, we'll take that encoded extrinsic. So let's go ahead and actually do this. So we've set up the call we want to do. We want to do a utility call. We're going to batch the calls. We're going to create an asset, and then we're going to mint that asset into the same account, all in one message. So we take that encoded call hash, we paste it here. We'll do a maximum of 5 Paseo, and now we need to bump these weights up. So we'll go up to 100,000 for proof size, and we'll just keep clicking up this one, and then in a bit, there it goes. And what's cool about the UI is it says when your call will actually be successful, because it does dry runs for you. So there we are. Now we can call the contract, sign the transaction, and we should actually see this over here. So we have the contract was called, we got an XCM was attempted, and now if we scroll down, there we go. An asset was created with the admin of our contract address with ID 50, and we actually issued some of that asset to Alice right here. Now, I personally, it may be a simple use case, but I think this is really cool because we have a contract right now that is not just limited to calling other contracts. It is using the actual parachain runtime, and is doing that because all of these are not contracts. These are pallets. These are modules, specialized functionality of our parachain that we can now use, right? So it opens up a whole new world of things that you can do with your contract. Now, this is just limited to one chain, right? Where, for example, say you want to do the same thing. You want to mint NFTs, or you want to use the multi-sig. Maybe you just want to transfer assets, whatever it is. But we can do these cool things. And I think the utility batching calls together is something that is kind of unique for contracts, where you can do this, have all of these calls batched in your program, right? You don't have to do a front end call to do one call and then another call and then another call. It's just all happening on chain. Now, local, I wouldn't say is boring, but let's actually go across chain now. Let's go and let's do something on the Paseo relay chain and the Polkadot relay chain, but the testnet of it. So I will duplicate this tab and Paseo. Once again, this is just testnets. Wait for that to load. Okay, so here we have the Paseo relay chain. And let's do a call. So we can do let's just do a balance transfer because it's a simple one. Because usually on the relay chain, there's not too much available. They kind of offload it into system chains like the people chain or the AssetHub. So kind of the same thing. We're going to do a transact on the relay chain. So that means we need the call data that the relay chain accepts. So we'll do a balance, transfer keep alive, and we want to transfer into Alice's account, and we'll use 10 Paseo. So we've got that encoded call data, which will be passed to the contract. And let me go ahead and scroll up some. So we're going to do a generic execute, which is kind of the same thing that we just looked at, where you've got the encoded extrinsic, the fee you can take, and then how much weight do you want to go up to. Now, note something different here. So before, because we were on POP network and it was using the relay chain's asset, the parent's asset, we used location parent. But in this case, because we are actually going to send the message to the relay chain, we can just use here because we're on the relay chain. So the asset, Paseo or dot, is just here. And then the destination we're sending to now is location parent. We're going to go up one level from POP network into the relay chain. Now the message is exactly the same as what we just looked at, because we're going to withdraw the asset and purchase execution time, because we have to use Paseo to spend fees so that the transaction can go through. And then we're going to call this instruction .transact, which says we're going to call this encoded extrinsic. And remember, the encode extrinsic is just this. So it's the encoded call data of balances, transfer keep alive, send to Alice with a value of 10. And then we send it. Now, just note, the difference here is we're no longer using XCM execute, which says execute this function or this message locally. Now we have this destination field, which is the parent, the relay chain, Polkadot or Paseo, and we pass in that message. So we can go over to here, we can copy that encoded call data, and we will do a generic execute now, paste in our call data, and we'll leave those all the same. Now, sorry, this isn't going away, so let me refresh the page real quick. Okay, so generic execute local, paste in the call data. We'll do 5, and then kind of keep increasing this until it's a little weird. So normally it should be, let me refresh the page one more time. Okay, generic execute local, code extrinsic 5. Dry run the XCM message to see exactly how much you have to use. And maybe we need to increase the fee. All right, this isn't going good. I don't know. Okay, generic execute. Decoding failed. Sorry about this. I don't know why this is failing right now. This should be working. Because normally what happened is you pass in all of the data and you just say, okay, this is how high we want to go. Okay, there we go. Now it's working. Contract call will be successful, and passing it out of extrinsic, we're going to call it. Now, there's one thing that will actually happen here, which is before, or when you look at these XCM messages, we're calling from the contract, and the contract is actually the one that has to pay the fees. So normally, when it's just on the POP network chain, it's got 1,000 Paseo. But we're actually sending this message now to the relay chain, and the contract doesn't have funds there. So we need to make sure it's funded. Now this is where that comes in, where you've got the calculated address on the relay chain. And we've got this handy then, this little helper right here. So cross-chain address. So we've got the relay chain public address, which is, if you wanted to look more into it, this is the actual public address that is generated. But the one that we care about is this one, this relay address right here. So we can copy that. And just to reiterate what this is a keyless account on the relay chain that only the contract, our contract on POP network can use. No other address or contract or whatever it is on any parachain can use it. Only the contract on POP network can control this address. So we need to send it some funds. So we'll go to Paseo, and we will transfer some funds over to this address. We'll just transfer 100 Paseo and submit. There we are. And now when we call that extrinsic, which remember is just a balance transfer, when it hits the relay chain, there's actually funds that can pay for this call. So you can go ahead and call contract, sign the transaction, and this will take a little bit to come through. But if we go to POP network, there we go. This time the XCM message was sent. So it's sent from the POP network chain up to the relay chain. And there's fees paid. Now when we come here, it takes a few blocks because it has to go up to the relay chain, and then the relay chain has to process it. But there we go. Look, so we've received one message. So upward message received from 4001. 4001 is the para ID of POP network. And look at that. So now we have the message processed, and it was a success because it was able to pay all the fees. And we were able to transfer assets from our contract address to Alice. So once again, it's a simple example of just a balance transfer, but it's really cool because we're doing it from a smart contract on POP network, calling and transferring funds on the relay chain. And it does this all natively. This is all built in directly because Ink uses the same XCM that Polkadot has because it's all built in Rust. Okay, so that was the relay chain. Now I'll move a little quickly because I realize we're running out of time, and I'm sure this is a lot of dense information, so you have some questions. So let's do one more where we're going to go to AssetHub. And AssetHub is, as it says, it's a system parachain that controls the assets for Polkadot, or in this case, Paseo. So we'll do the same thing. Let's go ahead and create an asset right here. And we kind of have to just choose a random asset ID that doesn't conflict with somebody else's. Excuse me. So if it lets me scroll. So there's not many here on Paseo, so we can just choose 500 is fine. So we'll choose ID 500, and the admin of it will be this account. Actually, we want the admin to be our contract. We want our contract to be the admin of an asset on an entire different chain. So we can do that by, once again, we'll go to this cross-chain address here, and we want the AssetHub address. So this is calculated for you, so you can just copy that. And we want it to be that one, and the minimum balance will just be 1. So we need to copy this data here and actually use it in our contract call. So I need to adjust something because right now for the contract, I only have a generic execute for the Polkadot Relay Chain. So if we were to just copy this real quick and paste, generic executes on AssetHub, and the location is something we can find from down here, or which one is it? Okay, so send funds. So the location is a little different. It's a little more complicated because for now I have to go up a level to the relay chain and then down to AssetHub. So where is it? Generic execute right there. So that is our destination. So we've got one junction, which is parachain 1000, and we've got one parent because we got to go up to the relay chain and then down. So if we are to use this, so okay, so it expects a versioned location. So what we have to do is we do versioned location and v4, and we pass that in here. Because just like the XCM messages are versioned, the locations are versioned as well, so that way it doesn't break. So we build that again, and this should all build nicely. Okay, there we are. And we actually have to deploy it. So there's a few steps involved here. So we deploy the contract. You know what? I think I'm actually going to stop it right here because you're just going to kind of see the same thing. So we've deployed the contract. We will fund this contract locally on Pop Network, so that way it can pay fees. And then we have to copy this AssetHub address and fund that on AssetHub as well. And then we can actually go ahead and use it by going to generic execute AssetHub. We pass in the extrinsic we want, which is this one, right? Which once again is just, we're going to create an asset, and this is the call data for it. So when it gets to AssetHub, it can actually take this call data, decode it, and then do this call. However, there's a few steps involved because we just had to create a new contract, and we got to do all of these fundings. So there's not much extra that you'll see except a cool XCM message on a new chain. So I'll go ahead and I will go back to the slides real quick. If I can find them, there we are. So on your own, if you want to dive deeper into this, I recommend read the XCM docs some and send some XCM messages. You can use Pop Network, you can contact me if you need some sale, and it doesn't necessarily need to be through Ink. You can just play around with it, send some messages to different chains, and then re-implement these basic functionalities we went over. Do a local transfer on Pop Network, transfer some funds to the relay chain, or do generic executions, and then make it your own. Now, some ideas is, as you saw, XCM is pretty dense. So what if there's a library that makes it easier to use, that people can just import into their Ink smart contracts and now use XCM in an easier way? What if you had a DAO that you could specify, it's like, hey, we want to do this call on AssetHub or HydraDX, whatever it is, to maybe stake some of our DOT or create a new asset or batch airdrop a bunch of assets or something like that. And the DAO can vote on if they want that XCM message to pass. And then what if maybe there's a contract that you could do with the configurations to actually update the encoded calls, where you've got a basic set of, we want to do these transactions, and then maybe through a multi-sig or a DAO, you can actually update what calls can happen. This is our Telegram right here. So I imagine you've got some questions or you want some links or something. If you go there, you can contact me, you can contact lots of other people from the Rogue team, and we're happy to help you out in any way possible. If you have questions on XCM or just Polkadot, we can help you there too. And if you want to follow us or check out our website to actually get some of these resources, it's simply just onpop.io. So the website is onpop.io, and then the Twitter or X is onpop.io. Now, I'll actually go ahead and call it there because I want to open up for some questions because I know this was pretty dense.
Yeah, very nice. And don't worry, everyone, the video is available to watch the recording, so you can go back through all the steps again and make sure you didn't miss anything. So we've got a few questions in the question tab. Are you able to see them, Peter?
Yep, I can see them.
I'll put them up on the screen one at a time so that the recording has them as well.
Okay, perfect. So what is the difference between substrate-based smart contract development and ink-based? So right now, there's a palette called palette contracts, and this is something deployed on substrate chains. Ink is the native one to Polkadot, but there's also some other ones like Solink, where you can compile Solidity into WASM. But that's kind of it. Ink development is substrate contract development. Is this keyless account pure proxy or similar to it? Is it controlled only by the smart contract or POP network? Yes, it is really, really similar to a pure proxy. So you're not going to use the proxy palettes. However, it is like a proxy because it's a proxy account that is only controlled by the smart contract on POP network. No other account can control it. So yeah, it is a proxy in a way. It's just not a pure proxy per se. So in the example XCM message, we have to withdraw the funds to pay a by execution. Is by execution the same as gas fees? Then after that, we transfer and deposit the funds to the beneficiary. Yes, exactly. So you have to pay the fees and purchase the execution to call into the parachain to do the balance transfer. And that takes fees. So when you buy execution, you're paying those fees. So first you withdraw the asset, which is DOT or Paseo, and then you purchase the execution to actually execute the message. You pay the fees for it with the by execution. And then yes, the next steps are it actually deposits the asset to the beneficiary. That was the last instruction. Is there any limits to the number of calls using generic execution? How do we measure the gas fee needed of such batch calls? So for every call you do, there's a weight associated with it. If you want to get really deep, you can actually look into the palette and see the weights, but there's a weight associated with each call. So when you batch these calls, it increases the weight for each of them. So it's like, okay, this one takes this much weight, and then this one takes this much weight. So the overall call is this much. It's basically the sum of those two. So there are limits to how much you can put in there, but you'd have to kind of add a lot because you'd have to hit the block weights. While instead you can just you have to pay the fees for all those individual transactions you're calling. Can an ink keyless account be set as proxy of another account? Yes, it can. So if you're familiar with the proxy palette, the way it works is you actually register a new proxy using some account. So if it was just Alice can say, I want to create a pure proxy. So what you would do is you've got your keyless account that is controlled by the smart contract, and then you do an XCM message to call the proxy palette, right? So you'd copy that encoded call data from the relay chain, and then you'd pass it into your contract, and then you'd call it. So then what would happen is you'd actually create a new proxy account from your ink keyless account. There's some layers to it, but yes, you can do that. What are the current problems that can be solved with POP? So what we're doing with POP is we want to make it simple to develop for Polkadot. And this XCM one, I realize it's still complicated. So we're doing some things to actually make it a little easier, where instead of having to do these XCM calls manually. It's just an API you call. Say, hey, I want to transfer an asset to AssetHub. So then you just call that function, and we will deal with the XCM message under the hood. However, if you want to get deeper, the XCM is there for you.
Very nice. That is all the questions in the question tab. I'll do a quick scan through the chat. But I think everyone put them in the question tab. The links that are being used in each workshop are being put in the description of the recording, which is posted on YouTube. So you should be able to find those nice and easily. I also posted the link to the XCM docs earlier on in this session if you want to grab that now. But it will be available for you tomorrow when the recording is posted. I think, there's one more question.
Okay. How is upgradability of contracts? So Ink upgradability is actually really, really cool. So you can do the proxy configurations that Solidity commonly has. But with Ink, you can actually update the code directly. So if you have that function provided, you have to register it because it is a privileged call. But you can register it, and then you can create a new contract and do essentially, you'll do an upgrade to upgrade the code. Now, if your storage changes, you can actually run migrations to update the structure of your storage. So just like parachains and Polkadot and Substrate can do forkless runtime upgrades, you can do kind of the same thing with Ink contracts.
And someone's asked if there's a GitHub link for the XCM calls we did today. Is there a demo link?
I will publish all of those so that way you can play around with it.
Very nice, thank you. So they'll be linked in the recording as well, so you'll have access to those as well, Mel. Okay, awesome. So unless anyone else has any more questions, those last slides at the end there had some good homeworks that you can do for those of you who are looking to get a certificate out of this bootcamp. You have to do a weekly homework. So some great ideas from Peter at the end. Thank you, Peter, for coming in and teaching us about multi-chain contracts. See everyone on Thursday for our next workshop, which I believe is indexing on Ink. So that's really exciting. We'll see you then, everyone. Thank you so much for coming.
Awesome. Thanks, everyone.